Now, look for what you have to maximize, look for what you have to minimize. That is going in the Y of your calculator. That's Y1. That has nothing to do with the variables that you create. Okay, so we're going to take your product and put your product into your Y1. So right away, Y1 is product. X times Y. I only have two numbers. Remember, this is the same let statement as above. 1 through 4 had the same let statement. X is a positive real number. Y is a positive real number. Okay, so now, we have to have another piece of information to substitute out that Y. So they gave us the sum of the first and twice the second, X plus 2Y, is 100. That's our second equation. Solve for Y in terms of X and substitute that back into here. Now, you don't have to distribute, you don't have to break anything up, just plug it right in. Put it in. I would use, if you don't use the fraction key, you have to have a separate set of parentheses for your numerator. Make sure before you hit enter or your graph or whatever it is you're looking at, make sure you check your parentheses. So if we're making our sum of our numbers add up to 100, even if I used 199 and 1, if I'm making a product, or if I took half of those numbers, 50 times 50, that's where I'm going to get my maxes from. So even if you did 50 times 50, and obviously it can't because it's twice the second, but even if you just did, you could get enough to get your window started. Again, you can look at your table. Easiest way to get it on your table is to change your delta sign. Don't let it go every 1. Let it go every 50 until you see it change. If you're a maximum, your Y's are increasing, hit a peak, and have to decrease. That's what you're looking for, is that peak. That's halfway through your graph. So when you find your X, double that. That is your Y max though. So work with it. Can everybody get this on their calculator or no?
Maximum was 105,000.
105,000? Okay, let's take a look. Check that you put it in correctly. Sometimes what happens, we make a mistake and we spend so much time trying to work on it. Just check that you have these parentheses in the right place. Which calculator are you using, Jeremiah? Okay, use the fraction key. Do you use the fraction key? Alpha Y equals? So put that guy in and then let's do it again. If your parentheses are in the wrong place, it's going to give you an entirely different thing. I know my calculator's pulling up now. If I don't have these extra parentheses, I'm doing x divided by 2 minus 100 times x, it's not going to work out okay. So be careful that you get everything in the right place. So let's put this in. And again, I don't think I have an alpha y equals on this. I might. If I do. Okay, so let me just clear this first. You got it? It was probably your parentheses, right? Okay. Now, again, you're going to set your windows so that you're in quadrant 1. Your mins are both to zeros. My max, if they add up to 100, let me just set it to 100. Maybe I have 100 and 0. That's well, 99 and 1. My Y max is what I have to work on. Now, say I didn't know where to change this. This is what you're looking at. You know it's there. Something's going on, but you can't see it. Look at your table. Start your table at 0. Start it at 0. If you can... What's wrong with this board today? If it's not going to take you too long, and you can see this over here, if it's increasing, it's going to reach a point where it's decreasing. Don't look at the fraction part if you don't need to look at the fraction part. See how far you can go. If you decide that it's increasing too far, change your table set, and this one's not going to be too far. Just go by tens. Go by tens and start looking. I see an increase, I see a decrease. So I judge it by 50 and I say double that. There's my X max, 100. There's my Y max, 1250. Let me make my Y max 1300, just so that I could see the top of it and I can see when I do my max that I could see the numbers that it shows. And you should be able to see it turn. If we didn't see it hit the ground in this case, I wouldn't really care. I wouldn't go about changing it again, because all you care about is your maximum. If you want to know how long it took to hit the ground, if we had that kind of a problem, then yeah, you'd have to change it. You okay with this problem? This is a pretty nice problem. Okay. Then I gave you number 7. We did 6. And you had to do, this is the one you had to do? Okay. This one works a little different. And now, again, it says minimize perimeter. So in my Y1, that's where my perimeter is. I have a rectangle that has a length and a width. So I've got my X and my Y. X is my length, Y is my width, or vice versa. It doesn't matter. And you have an area of 64 feet. So this is my first equation that's going to help me. Perimeter, 2 times the length plus 2 times the width, 2 times the length plus width. Doesn't matter to me which formula you use. So 2 times x times y, 2 times x plus y, that's the one I chose to use. You can use 2x plus 2y. It doesn't really matter, as long as you have a perimeter formula. We're going to substitute out your y. Take that out and substitute it into here. Now, don't forget, I'm looking for a minimum. This is my perimeter. When I get my answer back, that's my x value, but my y1 is my perimeter. I've got to bring it back to that equation so that I can find my y that I wanted to in my let statement. Now, your minimum works a little bit differently. Your x is still going to double, but obviously you don't need your highest y. You don't want to go too low, or you're going to have your little graph at the very top of your calculator. So you want to make it a reasonable graph. And if you can't see the sharpness to do the minimum, then change your x value. Make your x be a little bit longer, and it'll make that piece a little bit sharper. So if I put this in here, and use your fraction key, then you don't have to worry about any extra parentheses, because your parentheses will definitely throw off your equation. Okay, sometimes you can graph on an existing screen. Look how little that looks. So I might need to change, which part should I need to change? I'm going to change my x. Maybe my x is too far. I definitely have to change my y. So maybe my x, I'll make it go to 50, and my y really doesn't need to go that high at all. So maybe I'll make my y max go to 75. And to see. Can I see a curve? Yeah. If my x doesn't go that far, look what happens. I'll make my x go to 20. It makes my curve a little flatter. If you can still find your minimum without going too far over, you're fine. If not, make it sharper, like we did. We changed the x value. We made the x go to like 75, whatever we made it go to. And you can see how sharp it is. See how sharp it is? Your minimum is so much easier to find. You can definitely get around the minimum part. You guys good with this?
You just changed that to 75?
Yeah, you can play with it. Like, does it matter?
No.
No, I want to see it turn, number one. I want to be able to do a min or a max. The maxes are pretty straightforward. The mins, if you don't get your X high enough, they kind of flatten out a little bit. So you might want to make your X a little bit longer to see it make it get a little bit sharper. I don't like to drag my cursor around too long, so I like to make it sharper. Okay? When you get your point, remember that your XY is your perimeter. This is your X over here. This is your X. This is your perimeter, your minimum perimeter. So take this X side and put it back in here and find out your Y. Good? Questions on these at all? Everybody maximize and minimize? So whatever maximize, minimize goes in your Y1. Okay. And changing the graph is probably the hardest part. Good? Alicia, you good? All right. So let's try another one. What else did I give you here? This wasn't homework, but I do want to do this. Yes. I don't want you to see the... I don't know why this is not fixing anything. I can't erase it because it's already written. Hang on, guys. If I'm maximizing, which way is my parabola turning? Down. So let's see if you can get this on your calculator. You're going to have to play with your window. Use what we just said and see if you can get this to appear on your graph. Yes. Okay, it should open down, so something's missing.
Mine is like a straight line.
Something's definitely missing. Did I forget it?
Does that mean that's something for?
Something's wrong with the way you put it in.
What are we supposed to do?
It looks
Oh,
right to
minimum
me.
looks uncurved.
It looks right to me.
Mine is mine is why is it a straight line?
Yeah, because if it's a straight line, you got to change your window.
Oh, I tried.
Is it open up?
Your X max is just way too big. That's your problem. Because your speed can't be that big. Now we'll work with that. You might have to change your Y. Your speed, what did we say your speed was going to be, guys? Less than 60. It's not going to be greater than, so your X max can't be greater than 60. And go to your table and look at what your Y is.
It's gonna be less.
What kind of Y's are there? Decimals. So what do you think your Y max should be? 1, because didn't we say rates are percentages moved into decimals? So play with that. Max and min, that's what's happening to you. Oh my goodness.
Oh, finally.
Okay, but remember we kind of thought this out, guys. Watch. Your speed should probably not be any more than 60. The 65, 55, 65 is your congested roadway. Yeah, probably not more than 60. Your max here on your Y is a rate. A rate is a percent. But when we put it in a formula or an equation, we have to move it to a decimal. So your Y max should be 1. Because look at my table. I got my table set to 10, so let me set my tables to 0. Watch my table. Look at your rate and your Y. While I'm getting my graph here.
Oh.
I can't seem to get to my table. There it goes. Look at your rates, guys. Look. Your maximum says I should be increasing, and then decreasing. What kind of Y's do I have? Decimals. I got decimals. So Y max should be 1. So maybe I want to see, maybe I need to move up my speed a little bit. Right at 75, maybe you can see the whole thing turn. I just need to get my maximum here. Can we get a maximum out of this? Can you find your max? What'd you find for your max? 3 decimal places.
33.166.
Okay, this represents my x. X represents my maximum speed. This represents my flow rate. So my rate is actually flowing at about 75.4%. I have a flow rate of about 75%.
I didn't get that number.
It can't curve up. Change your window. Jeremiah, let's look at your window. Make your window look like mine. Your Y max has to be 1. Your Y max is too high if it's curving the other way. Try this. Your mins are 0, your X max is 75, your Y max is 1. We have rates out there for Y max. Okay, check your equation. Does it look like this? Are you missing a square? Make sure it has a square.
Yeah. That's me right here.
All right, let's figure this out.
Oh, I got it.
You have my alpha Y equal?
Got it.
Your alpha Y equal this one?
Oh,
Oh, you can't get this. Okay, let's take this. Let me see if this has this whole thing needs to be reset. All right, let's get to a different calc. I don't know, something's wrong with this calculator. Yeah, that's what's happening to you. Okay. Here you go, honey. I think the software got messed up on that. Okay, are we good with this now? All right, so you have another problem on there about a rancher or anything?
Yeah.
Yeah, number 9.
Farmer? A farmer plans to, good, okay. All right, so let's see if we can move on to our farmer. Is this the last one?
Yeah.
Okay, good. All right. Again, we're going to drive your windows crazy, but we're going to draw a picture and see if we can make sense out of this. A farmer plans to fence in a rectangular pasture adjacent to a river. So what do you visualize right now? A river. And here's your pasture. This is my pasture all in here. I plan to fence it in to make it a rectangle. So I plan to go like this. Do I have to fence in where the water is? No, because I'm going to use that as my boundary. Okay? The pasture must contain 180,000 square meters, sorry. This is my area. In order to provide enough grass for my herd. What dimensions would require the least amount of fencing? The fence that I put around here represents what? My area or my perimeter? My perimeter. So I am minimizing my perimeter. My Y1 has to say perimeter. So let's label our rectangle. I'm going to label my sides X and my length Y. So I'm going to let X equal my width. I'm going to let Y equal my length. Okay, good so far? How do I write my perimeter formula?
2x plus 1.
2x plus y, good. This is going to go into my y1. This is going to be my perimeter in here. Well, I got a problem. I can't work with that y in there. So I go look at the only other piece of information, and they told me that my area was equal to 180,000 square feet. So I have to solve for y in terms of x. So I divide both sides by x. Yes, because the river is there. I don't need to fence that part in. Normally on a rectangle, yes it is, Anisha, but this time the river is taking one of my sides away. I'm going to be nice and let them get water and wash themselves off and whatever. So now, I'm going to take this and I'm going to plug it into this Y. Now, I have my equation that's going to go into my y1. Is this, before you put it in, tell me, is this going to give me a parabola that opens up or down? Up. I'm a minimize. So it's not technically a parabola. It's part of a hyperbola, but close enough. We're going to get something like this. Now, let's look at these numbers first. Let's get it in your calculator, and let's just take a look at your table, just to see what we're looking at. Aren't these numbers kind of large?
Yeah.
These numbers are very large. So, remember before, every time we maximize area, they tend to stay together. Every time we minimize perimeter, that's where you're wanting to put your, your perimeter around here. Even if we took, well, let's put this in and let's let you figure this part out. I want to see if you can get a window out of this. See if you can get a window so that you can see your parabola. It will take me this long to get this in here. Jeremiah, is it working better now for alpha y equal? Good. Now I'm going to graph it, just because I really don't even know what this is going to look like. I'm just going to graph it anyway, maybe. I can't even move this. And I see absolutely nothing. Now my numbers are very large. I'm going to set my table set to start at 0 and go by hundreds, just because I know these numbers are large. I should be looking for my y to decrease, 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 and start to increase. Should I not? I should be decreasing, decreasing, and then increasing, right? So I see this decreasing, decreasing. Oh, I see an increase right in here. Do you see my increase? Even though my numbers are large and they're set far apart, it's okay with me. I'm only making a window. If I want to get it more defined, I could maybe go by 50s or 20s, 25s. But I only need a window. So I go to 400. I say, okay, double that. Make my X max 800. I'm halfway through. Make it 800. This is my close to my max. So make it like 1300 and let's see what we get. Let's just try it. Just play around. I want you to play around with it, because if you don't play around with it, you're not going to get comfortable. So we said, what were we making it? 800 was your max. And we said 1300. Okay, let's see if we see something. window range, that means you set the wrong one. That means you went to the min and not the max. So watch over here. Your min always has to be less than your max.
So I do have to combine.
Nope, just leave them like this. You're really only changing your maxes. Now, did you see where my graph was? Way up there. What should I change? The Y max, not the minimum. I want my minimum to be 0. I want to change my Y max. So, what should I make it?
1600.
Let's try 2000. Did I say 200? It did not go through. I don't think mine went through. Yeah, it didn't go in. My calculator is not very cooperative today.
Y equals 2x plus 18 from 180,000
Okay. Is this enough for me? I can find my minimum now? Okay, why are you quitting? Why are you quitting? And find my Y. When you take this X, you're going to go back to this equation over here, plug in your X, and get your Y. Sorry, they both wait, one of them is 300. Wait a second.
The X is 300.
The X is 300. I got to put 6 in there. Oh, darn. Okay, so one is 300 and one is 600.
The minimum though, how'd you get that? Because I got the minimum for the actual graph 312,000.
Oh, okay. What I did my X and Y different over on this sheet. Okay, we should have just did our minimum over there. So then your Y is 600. Do you see what's going to happen? It's either going to come out one of these. Are the dimensions the same?
Yeah.
Yeah. It depends on which one you called. On my paper, I called it the opposite way. So I called the X over here and the Y's over here. So mine just came out the opposite way, but is your dimension be exactly the same? Is your area the same? Your perimeters the same?
Yeah.
Yeah. Okay? Okay, that's a tough one. That's a tough one. And the only reason why it's really tough is because of your window. They develop your equations. We have a problem that says an object is shot from the top of a building, 300 feet tall. Oops, let me pick up my pen because you know that's going to happen. 300 feet tall with a velocity of 40 feet per second. Now, normally we give you the equation, and you plug the equation in, and everybody's like, never questions where the equation comes from. This is actually where it comes from. Why this didn't print out on your paper, I'm not sure, because I have it on mine, but it's not on yours. Now, this is your standard equation. Do you have to memorize this? Not at all. I just thought it would be interesting for you to see where this comes from. Your gravitational force, if anybody's taking physics, is right here. That's what actually pulls, when you throw something in the air, that's what pulls it back down. So normally, and I don't know if you remember from Algebra 2, a lot of the parabolas that you did always started out like this. Negative 16x squared. It always had that negative 16 over there. Yeah, and the reason it did is because it took half of negative 32. So your gravitational force
It's
is
always negative 32.
It's always negative 32, but the format for the equation is 1/2. Will I make you know that? No, but I just want you to know where this came from. I like to know where things originate. Now, your velocity is what comes in this middle. A lot of times kids say, how do they get that middle number? That's where your velocity comes from. The H, the last part, that's our y-intercept. That's how high we start. That's where your parabola begins. So what I want you to write is, what I want you to write is this equation on your paper. Well, I wanted you to understand where it comes from, but I want you to use this. So look, we plugged in your 32, and half of 32 is negative 16. Your velocity is 40, there's your velocity, and you are 300 feet off the ground when you shoot this in the air. When we cover this up, isn't your intercept 0, 300? Don't we always look at your y-intercept to see where your y-intercept is? Now, technically, your parabola comes from back here. It goes like this. We don't use this part because we're in application. But technically, that's where it comes from. It's got to have a place to begin other than here. We say, we don't want this because I can't have negative time, negative distance, blah, blah, blah. So I start where I'm standing on top of this building, 300 feet off the ground. So when you put this in your calculator, let's take a look at what you think your window is going to be. Let's do your window without looking at your table. Let's make sense out of this. So negative 16 x squared, put this in your calculator, plus your 40x, and your 300, that's how high off the ground you start. Now, before you graph this, let's go to your window. What do you think my x should be? How many seconds do you think it takes an object to go up and then hit the ground? Seconds. 15? Okay, let's try 15. Okay, if I'm already standing on a building that's 300 feet high, and I'm shooting up this object, what do you think my y max could be? Well, I'm already 300 feet off the ground.
500.
Well,
600.
okay, so let's go with 400. Let's go with 400. You're not that far off the ground, right? Okay, let's see if we see a graph. Ah, we see a graph, don't we? Now remember, this guy came from over here somewhere, which we don't care about. We just care about that maximum height, and this is when it hits the ground. These are my zeros. This is still my maximum. Okay, so you're going to finish that one for homework. You're going to do number 2 because it looks like the other one we did. And guys, listen. Number 1, number 2, and number 5. 1, 2, and 5. 3 and 4 will work together on Monday.
Monday's my birthday.